is rotated, the area cut off. So this area is rotated around. So this Pn is the radius of that elementary strip, and this area is extended from limit this to this. I'll take this 0, 0 point. Vertex is 0, 0. We know from this point to this point we have to find out the limits of this in terms of t. I'll take, okay, because at this t is 0 at O point, because I've taken parameter at square 280 parametric form of the coordinates of P are at square and 280. That's the point. Okay, now we have to find out that what is this ON, what is PN, what is OP, because we have to find out PN. So PN is OP, PN square is equal to OP square minus ON square. Now what is ON here, what is OP square, that we have to find out. Okay, then Pn will be calculated. Pn square is the radius. Pn square will be the radius for this solid which is generated, which is revolved around this chord. Chord is OL. Okay, so that area we have to find out then. That is the point here. We have to find out the radius Pn. That for that, then ON is the y coordinate of this point. Okay, so ON we have to DON we have to find out, and Pn square into, so pi Pn square into DON, that is the point here, volume of this curve, and limits are from 0 to this point, and for that we have to find out what is the value of t at L, what is the value of t, okay, parameter, and here at O it is 0 because A is 0, at square is 0, or twice at equal to 0, this is y coordinate 0, t equal to 0 on this O point. At this point, twice at equal to twice a, twice at equal to twice a. If I take y coordinate, so t is equal to 1. So 0 to 1 are the limits for this. So that is the point we will take. Now let me take solution of this point. So what is the curve here? Here the chord OL, okay, cuts the ellipse, the parabola, cuts the parabola at vertex O 0, 0, and one end L of lattice rectum. That is the point given to us of lattice rectum, and L coordinates are A and twice A. Okay, so we have to find out what is the equation of this chord. So equation of the chord OL is given by x2, this is y minus y1, y minus 0, equal to y2 minus y1, that means twice a minus 0 upon x2 minus x1, this is a minus x2, means a minus 0 into x minus x1, means x minus 0. So this is the value. That means y is equal to 2a only, 2x sorry, or y minus 2x equal to 0. This is the equation of this chord here. Y minus 2x equal to 0. Okay. Now we have to draw perpendicular from P to this chord. So equation of that Pn perpendicular. Okay, so let me find out Pn here. So Pn is perpendicular to OL. What is the perpendicular length? That is given by this equation. It will be equal to, because at y into y1, this P coordinates of P are 80 square. Okay, so if I put 1 into 80 square, so this is 80 square, sorry, this is x coordinate, upon 1 square plus 2 square means under root 3, that will be in the denominator. So Pn is perpendicular to OL. Therefore length Pn is equal to this, we are finding out perpendicular length of Pn. Pn is perpendicular to OL, so therefore Pn is equal to This we are calculating. So Pn is equal to x into epsilon means 80 square. This is 280 into 1. 280 into 1 minus sign twice into x coordinate is 80 square divided by under root of 1 square plus 2 square. That means 1 square plus 2 square is 1 square. This is the perpendicular length of this line. This is twice a. If I take common, t is also common. It will be 1 minus t divided by under root 5. This is the perpendicular length of Pn. So Pn is perpendicular on the chord. Okay, so chord equation of the chord is this. Perpendicular down from P point through this point. P point is this. We find out the multiplication of these 2 points. So this is the Pn value. Okay. Now Pn square is equal to OP square minus ON square. That we have to find out from triangles. Formula of the triangle here. The formula of the triangle here that we have to find out in this case. So formula of the triangle. Okay, so that is the value twice 80 into t minus 1 or 1 minus t, doesn't matter. This is t minus 1 or 1 minus t. Okay. First we have to find out this is because twice x minus y we can write. It is twice x minus y. But first we write twice x here. I'm sorry. Or twice x minus y equal to 0. In that way we have to write here. This is step b plus this is minus sign here. So it is t minus 1 in that situation. So it is twice 80. We have taken common. It is t minus 1. Okay, so this is Pn perpendicular length here. Now let me write here. Pn is equal to, therefore Pn is twice 80, with the bracket it is t minus 1 upon under root 5. This is perpendicular distance of a point P on the line. This is Pn is perpendicular on the line OL. Equation of the line OL is y minus 2x, so 2x minus y equal to 0. Because we first write x, then y. Twice x minus y equal to 0. So then this is the equation here. Twice 80, because x coordinate is coordinate of P. This into coefficient of x and y. Here it is 2 into 80 square. This is 2 into 80 square. Minus sign y. Y is 1 here, coefficient, and twice 80. So this is minus twice 80. 2a we have 280 we have taken common. This is t minus 1. Alright. This is the perpendicular length Pn. Okay. That I have written down here. Now let me rub this. But what is the Pn here? But Pn is Pn square. We know that Pn square is equal to. But Pn square we have to find out. This Pn square is equal to, or we find out On square. On square is OP square minus Pn square. That we can write. So On square, we have to find out On square because this length is to be calculated. That On square. So On square equal to OP square minus ON square, OP square minus Pn square. Okay. Now what is the OP square? These are two distance between 2 points 0, 0 and 80 square minus 280 square. So this is nothing but OP square is 80 square. Okay, 80 square minus this 0 means 80 square only. Okay, plus twice 80. Twice 80. Okay, so whole square of this OP, length of OP is x2 minus x1 whole square, sorry, this whole square, and 280 square. This is the value here. X2 minus x1 whole square plus by 2 minus by 1 whole square. X2 by 2 is x2 is 80 square, by 2 is 280, and here 0, 0. So x2 means 80 square minus 0 whole square, and this is value of OP square minus Pn square is this. This is 4a square t square into t minus 1 whole square upon 5. Try to understand. So this is the value of ON square we are calculating. ON square, why ON square is required? I'll just talk about this radius pi Pn square into, we write d into ON. This ON is the length of this contour. We may take that this is Pn, the perpendicular or the y coordinate of this is the x coordinate of this. Okay, so if I take this as y square and this is x at d into x, that we have to write here. Okay, that is the point. Now let me take this point here. So twice it is, so solving this, it will give us whole square. This is a square t4, but this is 4a square t square minus this is 4a square t square into t minus 1 whole square upon 5. What does it give? Just 4a square t square, a square t square, a square t square. If I take a square t square common, a square t square common throughout, so it will give us t square plus 4 only, t square plus 4 into 5, LCM are taking 5, minus this is 4 into t minus 1 whole square divided with 5 here. Let me solve it now. So what is this value? It will give us, let me write here. Therefore, ON square we are calculating. ON square is equal to this ON square. This ON square we are calculating. ON endpoint. ON square is equal to this value. This is a square t square with a bracket. Multiply this 5t square plus 20 minus. Now if I multiply this 4t square, it will be minus 4t square. Okay, minus 4t square, and this is t minus 1 whole square. If I open the whole square, it will give us minus 2. It will be minus 2t into 4 minus 8t plus 8 into t, then plus 1 will be there, but with minus sign it will be 4. It will be minus 4 only. Minus 4t square minus 4, and this is plus 8t divided by 5. So finally, what do we get? So we will obtain here, let me write it, further solving it. It will give us a square t square with the bracket 5t square minus 4t square, is t square only, and plus 8t and plus 16, because 20 minus 4 is 16. It is nothing but t plus 4 whole square upon 5. It is a square t square into t plus 4 whole square upon 5. Now square root we have to find out. So ON is equal to, this implies that ON will be square root of this. That means 80 into t plus 4 divided by under root 5. This is the value of ON. Okay. So now this is the value of ON here. So Pn and ON we have calculated here. So let me write this ON. ON is 80 into t plus 4 divided by under root 5. This is value ON. Therefore, the volume of the solid generated. Now this Pn is the radius of the elementary step. For limits, let me find out what are the limits here. Now limits for the chord OL from O to L are t. Here we have found the limits in t, because t is the variable here. So what are the limits of t here? It is 0. Because here y is 0, y is twice at 0, twice at equal to 0. or y equal to 0, equal to y equal to 0. That means twice at. So t equal to 0 here. You can take y or x, whatever. At square equal to 0. Here at square is also 0. This also implies that t equal to 0. Okay, in the second case, twice at is equal to twice a. This twice at, okay, twice at equal to twice a, because in terms of t we have to find out the value, limit of t. So this is any point on this ellipse, or this parabola. We have taken at square twice at p, and this also. So this twice a equal to this, because both coordinates are of the lying on the same parabola. Twice at equal to twice a. This implies that t equal to 1. So limits are 0 to 1. At O, limits are 0. I mean t is 0. At this L, t is 1. Alright. So limits are 0 to 1. This is the limit here. Now let me find the volume. Therefore, the volume of the solid obtained or generated by revolving the area, this OPLO about the chord OL. This we have to find out. So this volume is given by 0 to 1 limit in terms of t is pi into Pn square into t into On. Try to understand. This is d dt, or we may say d dt and dt. On, whatever value of On it is, it to be integrated, so differentiated with respect to t, and then this value is there. Okay, so that is the final value. That let me write here. Therefore, let me find here the volume. Therefore, the volume of this solid is equal to limits 0 to 1. Pn square is this square. It is 480 pi. Let me write pi outside. Pi are written outside. Pn square is this value is square. That means 4a square t square into t minus 1 whole square upon 5 here into dt of this On. So differentiating it with respect to t, at square it is plus 480. So let me take a. This is t minus 1. This is a. Integration of this will be t square is twice t plus 4 only, because into t it will be, so 4t integrated as t only, divided by under root 5 I have taken already. Okay, here On is also under root 5, so this is under root 5 here. On is upon under root 5. Okay, this will give us pi. Okay, now if I take a square outside, it will come out as 4. Okay, this is 2 also will come out, because 2 that is 4. So 2 if I take outside, this is 8 upon 5 root 5. So 4 into 0 to 1 here. Now leftover term is t square into t minus 1 whole square into 2t, sorry, t plus 2 only. But we have taken 2 common from this. 2 and 4, 8 pi upon 5 root 5 divided by into dt. This is the value which we have to integrate. So the terms of t. So now let me write it, integrate this. But before that, let me open this and multiply this by t plus 2. Okay, and that will give us the final value. So let me write here, this is 8 pi upon 5 root 5, and let me first open this is t square, or if I write it as t cube plus 2t square. This is one step, t plus 2 is multiplied by t square, and t minus 1 whole square is t square minus 2t plus 1, this dt is to be multiplied now. 8 pi upon 5 root 5, this is 5 root 5, multiplied by t, it will be 0 to 1. Let me multiply by t cube first, it is t5 minus 2t4 plus t cube, then by 2t square it will be plus 2t4, 2 to the 4 here, 4t cube, then 2t square plus 1, that means 2t square only into dt. Now let me assemble them, combine the similar terms or like terms. For 2t square, 4, okay, this 2t4 cancel out, t cube and minus 4t cube will be minus 3t cube plus 2t square. Okay, no problem. So that is giving us, let me write here. Therefore, the final volume, but before that let me summarize them. It is 8 pi upon 5 root 5. Before integration, let me further summarize this. This is t5 independent term, t5, then t cube and minus 4t cube, that means minus 3t cube plus 2t square only here, plus 2t square into dt. So integrating this further, 8 pi upon 5 root 5, integration will be t6 upon 6 minus 3t4 upon 4, t cube is integrated as this, plus 2t cube upon 3, t square is integrated as this, t cube upon 3, in 0 to 1 limit now. Putting the limits, what is the final value? Let me check it now. Therefore, the volume of this solid will be 8 pi upon 5 root 5. This is 1 upon 6 only, minus 3 upon 4 plus 2 by 3. Okay, now 12 is LCM. It is 8 pi 5 root 5. 12, if I take LCM, 6 2 is 12, this is 2 minus 4 3 is 12, this is minus 9, plus 3 4 is 12, 4 8. 8 plus 2 10 minus 9 is 1.12. It is 8 pi upon 12 into 5 root 5. 4 2 is 8, 4 3 is 12. It is 2 pi upon 15 root 3 root 5, sorry, 15 root 5. This is the final volume of that solid, which is generated by revolving that chord, revolving this area about the chord. Okay, that is the point here. The rectum is rotated through the 4 right angles about the, find the volume of the solid generated. So this is the volume, 2 pi by 15 root 5. Okay, this is what we have calculated. Now let me check whether answer is right or wrong. What is the answer of this question? Answer of this question will be, answer is, okay, something is coming. Okay, the 2 pi AQ is coming. AQ was there. I'm sorry friend, there was AQ also. 2 pi AQ is coming. AQ, I don't know why I have not taken it. A was coming here, I'm sorry. It was A square, so AQ I just forgot. AQ is here. Because I just rubbed it. But A is coming here in PN, ON also was having A here. This is 80. That is there. So it is 2 pi AQ upon 15 root 5. Get the answer here. Okay, if there is any might be mistake, but process is the same. Same with the process here. We have to find out this Pn is square pi Pn is square into don. Okay, on we calculated there. Only this solution is to be known to us. That is the point here. Okay, so 2 pi aq upon this value. Aq is coming because here it was a square. We have to do Pn square, so it is twice a square. Okay, for 4a square t square. So aq we took outside. I think that I just forgot. This is 2 pi aq upon 15/5. Or if it is something is coming here, some mistake is there, no problem. But answer is this. I mean, there's solution. This solution is there. Okay, so this is the question. Question number 7 we have done. If there is any minor mistake, I'll just check it. Okay, I'll recheck it and I'll tell you in the next lecture series. So I'll just talk about this. If there is any mistake, some calculus mistake may be there, but the process is the same. We have to find out Pn here. Pn square then pi Pn square into don. Okay, don we calculated the length of this on with the help of Pn and OP. OP is we have taken these two coordinates here, 80 square, 280 square. On parabola parametric coordinates we take 80 square, 280 square. So this will satisfy this equation. If I put 280 square in place of y, it will be 4a square t square. It is also 4a square because if I put x as 80 square, it will be 4a square t square. Same. This is satisfying the parabola equation. So we take any parametric point on the parabola 80 square and 280. Okay, that is the point here. This is the question number 7 we have done. Now 8th question let me take. For the question number 8, let me now check it. Okay, so it is coming 2 pi 80 square upon 5/5 coming. This is 5/5. But it is coming 12 here, so I'm sorry this cancelled out. It is 15/5, not 5/5. 2 pi aq upon 5/5 is coming. Answer is coming as 2 pi aq upon 5/5. It is coming 15. I don't know, some mistake. If I take LCM here, because this question is 2/3. Okay, 4/3/4, 1/6. The solution is coming 15/5, not 5. Maybe some minor mistake is done. So, but question is same type, of the same type. The process is same. Now let me take question number 8. From 8th question, it will be further obvious that what is the question here. What kind of that question 8th is. These 3 questions are of parametric form. Question number 8, let me talk about. What is the question number 8 here? Now question number 8. Okay, let me further clean it. Okay. Now question number 8 says that the quadrant of the ellipse x square upon a square pi square plus b square equal to 1 lying in the first quadrant, okay, revolved about the line joining the extremities of the major and minor axes, so that the volume of the solid generated is pi a square b square. Now answer is given here, so that will be very obvious. Now question is ellipse here. That is sorry, ellipse here. Yeah, ellipse. Let me take this ellipse as this is the ellipse here. X-axis O, X dash and Y dash axis. This is minor axis. This is major axis. And here it says the coordinates of this will be 0b. Here it is A0. Now it says that extremities of the minor and major axis. So one extremity is this. If I join these two extremities of the major axis, this is a point here, A0, and this is minor axis extremity. So these two are joined. So this area, okay, then it says the quadrant of the ellipse. This quadrant, one quadrant of the ellipse Okay, quadrant of the ellipse, this line in the first quadrant. Okay, this is the quadrant here. AB is the quadrant here. I'll take here again. Let me take P point or elementary strip again. This is P, this is Q point, this is N point, this is M point. P, Q, M, N. Again, this is the strip. We have to find out what are the coordinates of this point. Okay, A cos phi, B sin phi we will take, and O, P, N we have to find out, and A, N in terms of A, N we have to find out this. So this P, N square again, pi P, N square into D, A, N we have to find out. Okay, that is the same process here. Now what does it say? X square upon A square by square B square equal to 1. Line in the first quadrant revolved about the line. Okay, now this area, this arc, this is the arc of the first quadrant of the ellipse. That means AB arc is revolved about this chord AB. AB chord is obtained by joining the two extremities of the major and one extremity this of major axis and one extremity of the minor axis. That means A and B are joined. So if this area is revolved around AB, which is the chord here, okay, and extremity of the major and minor axis, show that the volume of the solid generated is this. Okay, that's the same type of question. Let me solve it. So in the first quadrant, revolved about the line joining the extremities of the major and minor axes. Major and minor axis, the extremities means A is the extremity of the major axis, B is the extremity of minor axis. These two are joined. Now this arc of the first quadrant is revolved around this chord or this line, which is AB line, which is obtained after joining the extremities of major and minor axis. Okay, that volume we have to find out. So this is the volume. The same way we will calculate what is Pn here. Okay, and Pn and then An we will calculate, and then what is this Pn? Pn is OP square minus An square. That we will calculate. An and Pn we have to find out. Okay, that's the point. And then coordinates. What are the coordinates of this? At this point, what is the value of this? Maybe x coordinate here, x to this. This is A2 or T. Let me convert this. Take point P. In the same way, we will take the A cos phi. If in terms of phi, we will take. So phi is 0 here. What is the phi here? Phi here will be pi by 2. 0 to pi by 2. That we will just discuss about. Now let me first take. This is the process here. So curve is there.